Right. Hello everyone. Can you hear me? Any issue with the audio and the video, just let me know first before we start. Okay, so hopefully the audio, everything is fine. And yeah, first of all, sorry if there's any lag. My laptop has not been upgraded in the past year, so it still lags a bit when I'm running streaming along with YouTube and my writing software. So if there's a bit of lag and it gets too bad, just let me know. Okay, so and also of course, if you want to invite your friends to join in, you have been comparing answers and you are arguing who is correct, you can just invite them to join in, and hopefully that will resolve your argument. Yeah, so yeah, this will be about 2.5 hours long, maybe a bit longer if we have a slightly longer break in between. So just make yourself comfortable. You've already taken the SMO this morning, and I hope it went okay by whatever standards you have. So if you have already done it this morning, you have had your fair share of math already. So take this as just a relaxed session where you find out how you did, and also if there's some question where you are very puzzled how to solve it, yeah, this is hopefully the time where you will understand a bit better. Yeah, now if you have to disappear at some point because of whatever reason, it's fine. This will remain available on YouTube, basically as long as YouTube is existing, because as you see from last year's one, which many of you watched, still here, and hopefully it'll be useful, in fact, for some of you who end up watching this before the 2023 SMO, which is the last thing on your mind right now. Now, when we do begin, just a little bit of ground rules for the chat. I can see there is a very active chat going on, which is fine. But when we are going through the questions, what you should do is just let me know if the stream cuts out or if the audio has any problems. Let me know if I say something really silly. I only saw these questions at about 1 or 1:30 p.m. I just got it not long ago, basically, and most of my time was spent formatting it and getting it ready for this stream. So if I did something silly with one of these questions, which is completely conceivable, feel free to say so in the chat. And if you think you have a better method than the one I'm suggesting, that's also entirely possible. Just let me know. So don't spam it, especially when we are going through the questions, so that I can see actual clarifications. And yeah, just be tactful with comments and discussions on your scores, because among everyone watching here, there'll be those of you who think 20 is a very lousy score, and there are those of you who are very happy with 7. Right, so this depends on your experience level, this depends on how much training you've had, this depends on how well you've done in the past. So just be tactful. Don't go saying that, oh, I got 24 upon 25, this is horrible, this is a horrible day. Don't do that. It is not going to be very nice. Okay, so yeah, you've seen this last year. What I would be doing is just to explain the key insights to the problems in more detail, and the computational steps in less detail. So I would assume that, let's say something like a simple expansion, a simple multiplication, I can just write down the numbers, and I'm not going to hold too long on those kinds of steps. Okay, and yeah, finally, this is not official, so there's a chance that something I did here is faster or slower, is better or worse than what the actual problem setter was intending. Right, I'm not the problem setter. I am just, like any of you, seeing the problems for the first time. Yeah, one more note. I've seen some of you discussing the cutoff for gold. There's no such thing as a cutoff for gold right now, because there is a second round. And because there is a second round, it means that the second round will determine the gold and the top 30 or top 10 awards. So right now, even if you got a perfect score, it doesn't guarantee you're going to get a gold. And if you're going to ask, well, how many questions do I need to get into the second round to get a gold? The answer is it depends on the second round. If the second round is particularly difficult, maybe one question is enough. The second round is particularly easy, maybe you need 3 questions. So it really depends on how the second round goes. But the difference is that, yeah, don't worry too much about 1 or 2 marks if you think you're going to qualify. I can't give a specific cutoff score. In the past, it has been like, before COVID, when there was a second round, it was in the ballpark of like around 14, 15 or 16. It could be a bit lower if this year's paper is considered to be more difficult. And also it depends how many people are participating nowadays. It depends on how many percent they want to let into the second round. So it's hard to say. Basically, I can't say too much about the cutoffs. Based on how all your friends felt it was like too easy, too difficult, that will be the best indication of how difficult it actually is. Yeah. Okay, so yeah, without further ado, let's get into the questions, which is why you're all here. For those of you who are waiting for the SMO senior one, I am doing that tomorrow. Tomorrow at 2:30 p.m. The reason is that if I do this junior one in the afternoon, the senior one will need to be in the evening, and it might end quite late, and I want you all to get a bit of sleep before the SMO open, just in case you're taking it. So that's why I'm only doing the junior one today. So if you're taking the SMO senior and you're waiting for that, it's not going to be in this video, it will be in the separate stream tomorrow. Right, so let's get started. I do suspect there might be some lag when I start writing. The reason why I'm still using this software is that in the past, I think I was explaining too quickly, and so the software automatically is slowing me down by its lag. So it controls it such that I'm explaining at about the right pace, and I think that's inadvertently a good thing. Okay, question 1. Which of these numbers is the largest? I found this kind of humorous because we have had so many questions like these. Normally it would be comparing the exponent or comparing the base, but this time you just calculate everything, right? It's small enough that you should just calculate all of them. So there is nothing more to be said than calculate all of them. 30 squared is 900, 10 cubed is 1000, 5 to the power of 4, 5 squared is 25, 25 squared is 625, 4 to the power of 5. Some of you know powers of 2. This is 2 to the power of 10, which is 1024. And 3 to the power of 6 is 729. You can calculate this quickly or you can calculate this slowly, but there isn't really a need to have a so-called smart way of comparing it. They're all very small. So congratulations to the vast majority of you who got this 1 mark on question 1. Yeah, so as I said, feel free to invite your friends in if you have any debates over some questions, and feel free to just walk aside, just stretch a little bit if you felt that, okay, all the first few questions were easy for me. I want to particularly see, let's say, question 4 and 5 or something like that. Just feel free to move around a little bit. Question 2. Adele has a fruit basket containing 1 apple, 2 bananas, and 3 oranges. Betty has a fruit basket containing 2 apples and 3 oranges. Assuming that Adele and Betty each randomly pick the fruit from her own basket. It's a bit grammatically wrong, it should be their own basket. Anyway, what's the probability that together they picked an apple and an orange? Now, indeed, probability is not part of the usual Sec 1 and Sec 2 or Year 1 and Year 2 syllabus, but it is something that you can kind of reason out, right? This is not a very complicated probability question. Now, the 2 ways this could happen is either Adele got the apple and Betty got the orange, or vice versa. So you have Adele and you have Betty, and the 2 fruits are apples and oranges. So either is apple orange or orange and apple. Now the chance of the first scenario would be 1 out of 6 fruits, that's the apple, and 3 out of 5 for the orange. Okay, so this is 1 over 10. The second scenario is 3 out of 6 times 2 out of 5, which is 1/5. So these are the two different scenarios in which the 1 apple and 1 orange happens, and you just add these up to get 3 over 10, which is option B. Yeah, I want to say that for this year's SMO, right, just a general comment, I think it is a pretty nicely set paper. The questions are quite interesting. So they managed to have a balance of, let's say, the front half has some familiar looking questions to reward those of you who have been doing revision and practice and looking at some of the past problems. And then the second half has some rather unusual questions. Now, unusual questions is actually kind of fun. It's just that while you are doing the SMO, you probably don't find it that fun. You find it very depressing or maybe a little bit irritating. Where did this question come from? Why am I supposed to know this? But these are interesting, and yeah, Olympiad should be a mix of the two, which is questions that if you're prepared for, you can do, and questions that preparation is entirely useless and you need to figure out stuff on the spot. So I think it's very fairly done this time, and yeah, but you have your own opinion having sat for the paper, so feel free to disagree and rage a little bit more internally at how it was like. Okay, question 3. Yeah, this is another one that I said about preparation, right? They have done this question very recently last year, so it came out again. Balances tip down to the heavier side, so we just need to look at the two different tipping points, which is there's one tipping point here and one tipping point here. Now the one down here just tells you that the triangle is lighter than the square. Right? This tells you that. Then we need to look at the thing across the two balances. Now across the two balances, this is supposed to be lighter than the collection on the right. That's heavier. So if we want to compare them, they both have a square which we can so-called cancel out. Now we know that the triangle is supposed to be lighter than the square, but overall on the right side it was heavier. So it means that if we compare the other two, the triangle must be heavier than the circle, right? So that the right side is still heavier, because otherwise if the triangle is the lighter than the square and lighter than the circle, the right side should be lighter as a whole, right? So this tells you that it should be in this order, which is option B. Okay, question 4, which is extremely long. If I'm being perfectly honest, I told you that I just saw the questions about slightly past 1 o'clock, and that was in a huge hurry, because that put me in a huge hurry because I had to get all of these stuff formatted and hopefully solved before the session itself. And so I was pretty unhappy to see a super long question like this. It is also possible that yeah, so some of you seen the answer that posted up from me, that I got none of the above, and there is some disagreement here. Now I'll explain my reasoning. And if it turns out that I've done something wrong because I misread something, that is entirely possible. But I'm about maybe 75 to 85% sure that I've understood it right. So let me explain how I got it, and then you can make your case if you think the answer, a lot of you say, is option D. Well, we'll see. Now, first of all, we know that there are 4 mathematicians and there are 4 combinations. Right? So I'm going to write it like this. The 4 mathematicians are A, B, C, and D. And then the 4 combinations are 3 cream, 2 cream, 1 gem, 1 cream, 2 gem, and 3 gem. Now we have to make some assumptions about this. And since the Singapore Math Society is the one that organized this, we can assume they think mathematicians are smart. We can also assume they think mathematicians are honest. So they are not going to tell you anything false. They're not going to tell you anything misleading, and they are not going to make wrong deductions. Right? Otherwise, we would just know nothing. We of course also have to assume everything in the question is accurate. So when it says gave each mathematician the wrong order, it means all wrong, right? Not just some are wrong. All 4 of them got mixed up. Okay, so let's go through the statements one by one. Firstly, mathematician A said, I ate 2 buns and both had cream filling. Now, assuming that this is a true statement, it means that it must have been he either received 3 cream or he received 2 cream, 1 jam. So if my order was wrong, I now know what my third bun is. So it means that if he can tell which one it is, he must have ordered either of these as well. Right, so I use O for ordered, R for received. He must have either he ordered 3 cream and got 2 cream, 1 gem, or he ordered 2 cream, 1 gem and actually got 3 cream. So we can cross out these other 2 possibilities. That's from the first statement. Yeah, words are too blur. Okay. I think it's a combination of yeah, this is a very long question, so I had to reduce the font. 2 is that because on my side there may be a bit of lag, so the resolution is not that good, and on the third point is that on your side maybe the resolution is not that good too if your internet is unstable. So I don't know what it is, but I unfortunately can't blow this up. So if you have just taken the SMO, I trust you have a copy of the questions. Maybe refer to that one on paper if you have to. Okay, so mathematician B then said, I only ate 1 bun and it had cream filling. Based on what A said, and since I remember A's order, I now know what type my other 2 buns are. Now this one is a little bit more tricky to pass, but here's how I reason it out. Now he can't have received 3 gem because that's what mathematician C received. He also can't have ordered 3 gem because if he ordered 3 gem and it was wrong, it could be any of the first 3. And excluding the one that A got, there's still 2 possibilities. So it cannot be 3 gem. Now, if let's say that B had ordered 3 cream. Let's say. Now, if he had ordered 3 cream, means that A did not order that. A ordered 2 cream, 1 gem and received 3 cream. In this case, B might have received 2 cream, 1 gem or 1 cream, 2 gem. And there's no way for B to know which one he or she received. And so therefore, it cannot have been that B received 3 cream. And by the same reasoning, B could also not have received 2 cream and 1 gem. So it means that B must have received, must have ordered. He couldn't have ordered 3 cream, he couldn't have ordered 2 cream, 1 gem, so he must have ordered 1 cream and 2 gem. And so he received whichever one A did not receive. Now we're not sure which one A did not receive, but received one of these 2. Now, C said, I've not started eating, but I must have received 3 gem buns. So C received this. Now if C received this, it means that he did not have the same order as B. So he must have ordered either 3 cream or 2 cream, 1 gem. Now for some of you who solve a bit of Sudoku, what we have here is kind of like a hidden pair or naked pair in Sudoku terms. If you have no idea what that is, the point is we don't know how this is resolved. Like who received what, and we also don't know how the orders are. See, we don't know who ordered what, but we know it must be either combination. So the only way that you can resolve mathematician D is that he must have received 1 cream, 2 gem, and ordered 3 gem, which is none of the options there. So the answer that I got is E, and I will just take this as this is my reasoning. I don't see anything wrong with it. So unless you have some particular reason why that's incorrect, I would take this to be the case. Okay, so there's a little bit of debate here. This happens for all the logic questions, right? I'm sure you know the Cheryl's birthday thing. There's some other interpretation of the language in the question that may potentially have caused you to legitimately deduce something else. Now, depending on how that other interpretation is and whether the Singapore Math Society considers that to be reasonable, perhaps they might accept your answer. But I really don't know, because this is my interpretation and I don't know what your interpretation is. But there have been instances in many competitions for this sort of logic questions where if it turns out that enough people gave the other answer and they realized that it was a bit vague, they may accept the alternative answer. So that's completely dependent on the graders. Okay, finally for the MCQ, the last question 5. If n can take the value of any positive integer, how many distinct values can this expression take? And remember, this is the floor function, which should be on the cover page of your paper, right? It means round down. Now, the first thing that one would notice is that, yeah, all these numbers are quite related, right? 4, 7, 14, and 28. They all have the same factors of 2 and 7. Now, in fact, we can say that n over 4 is equal to n over 7 plus n over 14 plus n over 28. Now, what this is implying is that it's not going to be infinitely many, because if you didn't have the floor, then actually it would be 0. Right? For example, if you put in n equals to 28, where there's no rounding down, it would be 7 minus 4 minus 2 minus 1, which is 0. So if there's no rounding, it would be 0. Now, I want to just say that for such a question, if I were taking the SMO, it's pretty simple then. You just try the numbers from 1 to 28, and not all the numbers from 1 to 28. You just try out every time when a multiple is hit. You see what happens to the total. So for example, you just go at first when n equals to 1, it is 0. You go until it reaches 4. At n equals to 4, it becomes 1. And then you continue until at n equals to 7. This one is going to be 1, so it goes back to 0 again. N equals to 8, it becomes 2 minus 1 minus 0 minus 0, so it's back to 1 again. and then at 12 it reaches 2, and then at 14 it goes back to 0 because both the 7 and 14 will now hit the next integer. And you can go on like this. So this is very practical. If you're taking the SMO, this sort of solution is just for getting an answer. Right? It's not going to be very ideal for round 2 if you write it like this, but if it's for round 1, just try out and you'll be fine. So at 20, it will go back to 2 again. At 21, it will go back down to 1. At 24, it will go back up to 2, and then when you hit 28, it goes back to 0 again. So it only passes through 0, 1, and 2. If you go with this sort of very direct approach, it also gives you the answer. Right? So in this case, it can be 0, 1, or 2, which means there are 3 possible values. Now, just a quick remark on how you would potentially write a solution like this a bit more formally, right? Rather than just a whole lot of dot 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 here, dot 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 there, dot dot here, dot 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 there. If we were to write it out, how do we know that it can never be 3 or higher? I can take away the floor functions. And do something like this. Now, in the best case scenario, which means that the largest possible would be when n over 4 doesn't get rounded down, and n over 7, n over 14, n over 28 get rounded down as much as possible. Now, if it gets rounded up as much as possible, you cannot round down by more than 1, right? Because you're rounding down only. So this is the worst case in terms of having as small as possible, each of these. And remember that I mentioned these are all going to add up to n over 4. So this is equal to 3, telling you that this is less than 3. Okay, so this also does confirm why it's an integer, so it can only be 0, 1, or 2. Okay, so this is the more so-called clever way to understand it, but the way on the left is more than enough to get an answer. Okay, we'll do maybe a few more questions, something like up to question 9 or 10, and then we'll just take a very short break. Okay, so for question 6, let n be a positive integer. The lowest common multiple of n and 12 is 60. The highest common factor of n and 36 is 4. This is a, I think, familiar question, right? Another one where the SMO decides that, okay, if you have done some practice, this will look immensely familiar. So usually how I look at this is by prime factorization, even though it's very guessable. So very easy to guess if you just tried out a few factors of 60. I'll just write down the statements in terms of prime factorization for, especially for the purpose of anyone who ends up watching this a year later, right? This is how you're supposed to solve such questions in general, even though for the specific of 12, 36, 60, and 4, it's so small that you can guess. Okay, so what does this all mean? It means that n is going to be 2 to the power of something, 3 to the power of something, and 5 to the power of something, because it has to be a factor. And we just fill up the powers one by one based on these two pieces of information. Now, we know that 2 squared must be a factor, and yet it must fit within 2 squared. So this must be 2 based on both of these. we also know that for 3 is not a factor of n because there is nothing down here. So there's no 3. And finally, we see a 5 down here. The 5 was nowhere to be found in 2 squared times 3. So if it is part of the lowest common multiple, the 5 must have come from n. So n is just 2 squared times 5 equals to 20. Yeah, again, can be guessed. So I just want to explain how you can handle these sorts of questions in general, but there is absolutely no need to write out something like this. Okay, question 7. Digits 1 to 6 are arranged to form 2 positive integers with each digit appearing exactly once. How many ways can this be done if the sum of the 2 integers is 570? Now you can start from a lot of places, but effectively you want most of the time to look at the last digit. Now the last digit here being 0 means that the only way you can have 2 of these digits summing to 0 is 4 and 6. Yeah, I mean, something that I didn't explicitly say, but it's pretty obvious, is that it must be a 3-digit plus 3-digit. So we get to write it in this way, which looks strangely reminiscent of something you probably did in primary school for some competitions. Now, because it says arranged to form 2 positive integers, my assumption here is that order does not matter, meaning that if you have the digit 4 in the first number and the digit 6 in the second number, that doesn't make a difference from if it were the other way around. So I'll just put 4 and 6 like this. And there's a carryover of 1. Now you're left with finding 2 digits that sum to 6 and 2 digits that sum to 5. Now, obviously, the only way that can happen is 1 plus 5 is 6 and 2 plus 3 is 5, right, among the 4 remaining digits. Yeah, so within these two, your choices are 1 and 5 in some order, and within these two, your choices are 2 and 3 in some order. So you can flip both of them around, you can flip both of them around, so that simply gives you 2 times 2 equals to 4 ways. Yeah, now most of you are at home or maybe you are just somewhere away from school, that is, for many of you. A general thing that happens is that everyone overestimates their score after the SMO, and about the time when you reach home and whenever it is you find out the answers, whether through here, through your friend, through your teacher, whatever it is, you realize that, oops, I scored about 2 or 3 less than I thought I would. This happens to almost everybody. So if you want to compare your scores to what your friends told you, right, remember, don't compare it to what they told you they got, because they probably lost as many marks on careless mistakes as you did. So if you thought that, oh, everyone scored about 20, probably they did not score about 20. This is what has happened for a really, really long time. Yeah, about the switching thing, my assumption is when it says arrange to form 2 positive integers, and how many ways can this be done? There's no mention of the order of positive integers, right? So if you did something like 214 plus 356 versus 356 plus 214, that would be the same thing, right? So these are the same 2 positive integers. So my interpretation is that the order of the positive integers does not matter, because it doesn't say 2 positive integers x and y. Then it matters which one is x, which one is y, but it doesn't say that. So this is my interpretation of the question. Question 8. Consider the following product of two mixed fractions. Now, this is the sort of question where if you got the answer, you know you're correct, right? Because there isn't really any way you can get this wrong unless you really multiplied wrongly. So that's a good thing. Now, once again, this one can kind of be guessed because they are quite small, right? Two mixed fractions multiplying to 23 means that both of them can't be too big. But here's how I would prefer to do it. I would write both of these as improper fractions first before doing anything else. Right, so I convert both of these to improper fractions and then I multiply over the 7 and the 3. So 7n plus 6, 3n plus 1 equals to 7 times 3 times 23. Now notice that I am not multiplying them together because I need to redistribute the factors so that they would fall into the 7n plus 6 and the 3n plus 1. Now, none of these combinations of none of these three factors, 7, 3, or 23, would be expressible as in the form 7n plus 6. They are not congruent to 6 mod 7. So if you try the other combination, which doesn't involve 7, you can combine these two together, and so 69 would be expressible in the form 7n plus 6. And 7 is also expressible in the form 3n plus 1. Okay, so this means that m is equal to 9 and n equals to 2. And you get 11 as the sum. Yeah, this has to be the only way. If you did something like n equals to 0, that's not correct, and I don't think that will anyway. But m and n cannot be 0, cannot be negative, so they have to be positive, and so that's why when we look at splitting the factors, we just look at 7, 3, and 23. There's no need to search for anything else. M and n are positive integers. Question 9. Another one that looks pretty similar to what we had the last time, to do with last 4 digits again. So I said the front half has a bit of questions rewarding you for effort, so to speak, by reviewing last year's questions and the couple of years before that. As you would hopefully realize, last 4 digits means you only need to focus on, well, the last 4 digits, which will be 0022 for everything behind here. So since all the things behind are only going to have 0022, we just add 222 plus 2022 plus 22 times how many of them are there? Well, it goes from 2 zeros to 10 zeros. So 1 to 10, there are 10 numbers, 2 to 10, there are 9 numbers. So 22 times 9. Okay. So the sum should be 2442. Okay, yeah, we'll do one more question and then we'll take a short break. So question 10. If a and b are distinct solutions to the equation x squared plus 10x plus 20 equals to 0, what is the value of a to the power of 4 plus b to the power of 4? There are a few ways to solve this question which are all fine. It depends on whether you are more comfortable with thinking of algebra ideas, or if you're more comfortable with just, massive expansion, and you know your binomial theorem and you know how to expand massive expressions with surds. Both ways would give you the same answer, but I'll present the one that looks a little bit nicer, does not involve expanding a huge pile of surds. Okay, so how do we do this? First of all, A and B are distinct solutions to this equation. It means that if we substitute A and B into the equation, that would be true. Second of all, from Vieta's formulas, we would know the sum and product of A and B. So I'll write that down. A plus B is -10, and AB equals to 20. This is from your sum and product of roots of a quadratic. Now, once you have this, how do we get to A to the 4 plus B to the 4? Well, we start off with combining these two to get A squared plus B squared. We square A plus B minus 2AB, and this would be equal to 100 minus 40 is 60. And then we do it again. We square it one more time to get to A to the 4. So A squared plus B squared squared gives you A to the 4, B to the 4, and also the middle term 2A squared B squared. Now, we already know A squared plus B squared from above, and we know A squared B squared is just AB squared. So this gives you 2800. Yeah, so in this way, you do not need to complete the squares, solve for x to be -5 plus minus square root 5, take fourth powers, expand and cancel. This gets you straight to the point. Alright, so we will take a quick 5-minute break here. If you want to invite some of your friends in, do that. If you want to just stretch out, also do that. And I think the next half would be the more fun half, so to speak. Okay, so we'll get there in a very short while. A few things to mention. Seeing your very lively chat. I don't know whether the difficulty of a paper is being evaluated correctly. Because if you look at like the last 10 questions, which are mostly difficult, that doesn't really affect something like a bronze or honorable mention at all, right? Because for a bronze and honorable mention, it depends on like the easiest 10 questions, not the hardest 10 questions. So if the back 10 is extremely difficult or just slightly difficult, it makes no difference to those, right? And a lot of you guys are talking about taking senior during the coming year. If you want to get a preview of how senior is like, just join in tomorrow and you will see it is not easy necessarily because it is senior, but it's not difficult because of difficulty of question. It's difficult because of content. So you would need to be learning more geometry. You'll be learning trigonometry, logarithms, polynomials, a bit more on surds. You'll need to learn coordinate geometry. You will need to basically learn more stuff. It's not because the questions are harder, it's just that it is in line with the year 3 and year 4 syllabus in most schools. So that's what will happen for senior, and it will of course not look easy right now, but no harm just taking a look to know like what you need to be able to do for if you're continuing to do Olympiads for senior next year, and if you're doing junior next year, then you get one more chance at this. Again, to reiterate, for something like the gold cutoff, it depends on the second round difficulty a lot. Now, obviously, if let's say the cutoff for this first round, let's say the cutoff is somewhere about 14, or maybe it's a bit 13, maybe it's 15. I don't know exactly what, but let's say the cutoff is around there. Now, if someone gets 25 for round 1, obviously that's a huge advantage, right? Because if you get 25 for round 1, you basically kind of get one free question compared to someone who got 15. But for most of you, if let's say you're in the range of plus minus 5 points, the first thing I would tell my own students if I'm preparing them for round 2 is that it doesn't really matter that much. Because if you solve one more question, it makes up the entire deficit already. So don't worry too much about exactly what you scored. And the only time where you should worry about exactly what you scored is, I don't know if there's anyone here that is hoping to get first place for the SMO. Now, if that is the case, it can happen, because my experience was that I have gotten perfect score for round 2 before without getting first place because I lost out on round 1. Now, if you're aiming for first place, it does matter. But if you're aiming for, let's say, a top 30 space, or if you're aiming for a round 2 qualification, it does not matter exactly what you got. Right? So just pick up any pointers that you feel are useful from here, and that's enough. Okay, and then before I start, I should do the YouTube thing of please like and subscribe to this channel, and please continue to watch whatever stuff comes out in the next coming weeks or so. Okay, let's continue and look at this star question. At first, when I looked at this star question, I was a bit puzzled because I was wondering what's the information. Like, what are they telling us? And I assume that in order for you to make any sense of this, it's supposed to be symmetric. So I assume they are saying that you're connecting to the midpoints. If it's not connecting to the midpoints, then you could kind of draw it any way you like, and the areas would no longer be fixed. So I have to presume all of these are 15 each when cut out from the square of side length 30. Right, that's the most logical interpretation. Don't need all of these, I'm just writing it down. Now, to emphasize that all of these triangles are all going to be congruent to each other by symmetry. So you just need to find the area of one of them, and that's good enough. Now, I want to allege that these are right-angled triangles. Okay. Now, that will make a huge difference in us solving the question. If you want to explain why this is a right angle, the easiest way to understand is just to rotate the figure 90 degrees, right? If let's say that you rotate this line, oops, I missed. Let me try again. If you rotate this line here, and then you imagine the whole square gets rotated counterclockwise 90 degrees. Now this line is going to end up down here. So if you rotate the figure 90 degrees and it ends up down there, it means that the angle is 90 degrees. Now, why is that important? Now, that's important because whenever you have a right-angled triangle and you draw another perpendicular, you get similar triangles. So the similar triangle would be between this big triangle and the small triangle down here. Now the big triangle is in the ratio 1:2. So the ratio tells you that it is a 1, 2, square root 5 triangle in terms of ratio. So this small triangle is going to be similar to that as well. And so it is going to be in the ratio 1:5 with 15. So it would be equal to 15 over square root 5. Multiply square root 5 to top and bottom. It is equal to 3 square root 5. So this is 3 square root 5. And because of the 1:2 ratio, the other side is 6 square root 5. So you have 3 square root 5, 6 square root 5, and so the area of each triangle is half times 3 root 5 times 6 root 5 is equal to 45. To find the area of the star, you take the whole square, the whole square, and subtract off 8 of these triangles. So that gives you 540. Yeah, okay, so the last for the last time, let me address some of the things about cutoff scores. Yeah, so I think it's reasonable sounding that the honorable mention cutoff will be something like 6 or 7, bronze would be something like 8, 9 or 10, and silver would be cutting off somewhere at about 12 or 13. Now, if you get into round 2, you're guaranteed a silver or better because the silver cutoff is about 1 or 2 points lower than the round 2 cutoff. That means that if you might be able to get a silver without getting into round 2, and if you get into round 2, you are guaranteed at least a silver. That's what it means. So if you just miss round 2 by 1 point, you're getting a silver. That's more or less what usually happens. And the exact cutoffs, I can't say. Alright, let us continue to question 12. This is a bit unfortunate because it is a recurring question in the SMO senior for quite a few occasions. Not because it's difficult, but it's just somehow it recurred there, and for junior it doesn't appear that much. But it is a very, very simple concept. How many solutions are there to this equation? You just need to ask yourself, how can you get something to the power of something to be equal to 1? And there are 3 possibilities when a to the power of b equals to 1. And I say 3 possibilities if some of you just jumped. That's why you got the question wrong. The first possibility is b is 0 because anything to the power of 0 is 1. Second possibility is a equals to 1 because 1 to the power of anything is 1. And the third possibility is that a is negative 1 and b is even in some sense. Now I say even in some sense because if it is a rational number, it can have an even numerator that's good enough, right? Negative 1 to the 2/3, for example, is still going to be 1. So once you know this, then this question just splits into three very simple cases that you track. And you'll find that each of them really gives you something. So either x plus 5 is 0, and you get x is negative 5. That's one solution. 3x plus 2 equals to 1, and you get x equals to negative 1/3. That's also a solution, because negative 1/3 in the power, it gives you 1 to the power of 4 and 2/3. That's still 1, it doesn't matter. And the third case is 3x plus 2 equals to negative 1, and that gives you x equals to negative 1. And it will be negative 1 to the power of 4. There's still 1, so that's still okay. So therefore, you get 3 solutions. The second round of the SMO is on the 25th of June, right? It's the last Saturday of the June holiday. So, and because there's a round 2 papers take time to mark. They are marked by actual human beings, and usually it's marked by 2 of the IMO trainers who have to mark the junior, senior, and open second round. Yeah, so they will be pretty exhausted because there are a lot of unintelligible proofs that they have to try to understand. So it will probably take a while for results to come out. As compared to the past couple of years when there was no round 2, that is. Okay, question 13. Now I have a bit of a love-hate relationship with these kinds of questions, because when it is nice, it can be quite logically explained. When it's not nice, you just have to go through a huge pile of trial and error. I actually quite like this one, because this is not so bad. This one can be reasoned out logically without any guess and check, which is rare. The SMO does not always choose to be so considerate, so I do kind of like this question among alphamatics or cryptorhythms. Okay, so let's write down what they tell us. They tell us W equals to 5. Oh, that's all they tell us, right? W equals to 5. The first thing usually that happens for such questions is that I will look at if the number of digits does not agree. Here the number of digits does not agree. So it tells you that the two 5-digit numbers are at most 90,000 and something. You add them together, you're going to have less than 200,000. So n must be 1, which is the standard starting point, and I'll put that in. Now, where do we go to next? Now, usually I would just scan through all of the different place values to look for the most interesting thing. And I believe the most interesting thing is in the tens place. O plus T equals to O. Now, why is this interesting? It's interesting because O plus T equals to O should not be able to happen, because if there's no carryover, then T is 0. And that does not work, right? Because the first digit cannot be 0, and that would not add up to 100,000 even if we did allow it, right? So it means that there must have been a carryover from here, which, I mean, we could also have concluded from the fact that they sum to 1, which cannot happen. And it means that T is equal to 9. Okay. So that 1 plus 9 is 10. So we can put a 9 down there. And there will also be a carryover to here. Now the 9 and 9 also comes here. And because there's a 9 and 9, we can say that if there's a carry, it will give you 9. Which is not allowed because that will repeat. So there's no carry, and E equals to 8. I'll put a 0 here just to remind ourselves there's no carry. Now there's no carry has implications on the thousands place. Because if there's no carry, then you have two digits that are summing up to 5. Which is quite something. Now, because there are two digits that sum up to 5, it tells you that, well, O has to be less than 5. Or less than or equal to 5 maybe, but it cannot be 5 because it's repeated, so it's just less than 5. If O is less than 5, that means there's no carryover from the hundreds place. And so you need two digits that sum to 5. And the only way that you can have two digits summing up to 5 without repetition is either 1 plus 4 or 2 plus 3, but 1's already taken. So R and O are 2 and 3 in some order. And now we go to the O's in the hundreds place. In the hundreds place, we have O plus O, gives you S with a carryover of 1. Now if O is 2, then S would be 5, which is a repeat. So it means that O is 3. And that fills up basically everything. So O is 3. Here there's a carryover, so S is 7. R plus 3 is 5, so R is 2. And then P plus 7 gives you 1, so P is 4. Okay, so you get an answer that many of you have been very excitedly typing in the chat. But the good news is just for once, there is no need to really do any guess and check for this arithmetic. Okay, question 14. In the following diagram, a white square and 4 grey squares of equal size are drawn in a circle such that both dashed lines form diameters of the circle. Diameter is length 60. Find the smallest possible value for the total area of the 5 squares. Normally this would be a question where they would give you some very fixed configuration and ask you what is the area. But here they say what is the smallest possible value. So that set me thinking, right? If it's the smallest possible value, then what is allowed to change? And the answer to that question is that even though this is the radius and this is 30, right, diameter is 60, so radius is 30, but how that 30 is being split up is not fixed. So I'm just going to call these two parts X and Y. Hope no one is having issues seeing it. I'll use a darker color. X and Y. So X and Y must add up to 30. And what is the total area of the 5 squares? Well, the total area for the white square in the middle, it is 4 of these small y by y squares. So it is 4y squared. For the shaded squares, because this is having diagonal x, so each of these shaded squares, the area is half x squared. And you can see this by drawing in the other diagonal. If you want, that's also x. You can rearrange it into half a square or whatever you like. So 4 times of half x squared for the 4 shaded squares. And so this is how we get 4y squared plus 2x squared. I just want to throw in a bit of a tidbit here. Some of you have swam over from the senior, from taking the senior, and you're just waiting, so you feel like you need something to occupy your brain. This question can be solved by Cauchy-Schwarz, which is not in the junior syllabus. So I'll just mention that first. It can be solved by Cauchy-Schwarz, and the way that you would solve it is very similar to how you would solve question 16 of the senior paper in using Cauchy-Schwarz. So I'll just mention That, for those of you who know what Cauchy-Schwarz is, if you don't know, I'll just come back to completing the square later, which is, a lot more down to earth. Right, so Cauchy-Schwarz will be applied like this. Oops, I'm missing a 2. Yeah, this would be how you use Cauchy-Schwarz. Okay, which is 30 squared. So it means that 4y squared plus 2x squared, yeah, this is 3/4, so it is greater than or equals to 4 over 3 times 30 squared, which is 1200. Yeah, so I'm just writing that there as a little bit of extra trivia, but I'm going to get back to completing the square and stuff that you're all familiar with. Okay, I have to emphasize again, the purpose of this stream, of course, is in part to let you check your answers and know how you did, but also it is meant to be a little bit of learning, especially those of you who will be taking the SMO Junior after seeing this, whether it be next year or if you're watching this on replay very close to the actual SMO, whatever it may be. So yeah, try to understand it, not just to be too hung up with what you scored, especially if you're taking open tomorrow. Don't be hung up on what you scored for this. There's nothing much that can be done at this point. Anyway, coming back to here, if you want to solve it by a simple approach, you would just substitute y equals to 30 minus x into here and complete the square. Okay, so complete the square is something that I'm just going to take for granted here. And you get 6x minus 20 squared plus 1200. So the minimum value is going to be 1200 when x equals to 20 and y is 10. Yeah, so this is a straightforward solution in the sense that nothing high powered. Okay, question 15. In the following diagram, ABC is a triangle. D lies on AB such that the ratio of AD to DB is 3:4. And that's actually the only numerical information you get. The only other thing that you get here is the parallelogram information, which I'm going to just highlight the opposite side so that we don't forget it is a parallelogram. Because it is so sparse, right, the diagram hardly has anything. So you know that you need to really squeeze out as much as you can out of this parallelogram. In other words, it is not just important that it is a parallelogram where the opposite sides are parallel, it's also important that the opposite sides are equal. So you need to use both the fact that they are equal and they are parallel in order to do this. Okay, so how do we make use of these ratios? I'm just going to copy over the ratio in as many places as I can. Now, first of all, because of the blue parallel lines, the 3:4 is also going to come here. AE to EC. Then after that, because of the red parallel lines, the 3:4 is also going to come to here. And furthermore, you can also see that DF to FC is also going to be 3:4 by more parallel lines. Right, what I'm using here is, if the diagram is too complex for you to see what I'm trying to say, what I'm trying to say is that if you just have parallel lines, in this sort of pyramid shape, then if this is in the ratio A is to B, the other side will also be in the ratio A is to B. This is all I'm saying. Okay, and this is basically enough. Because that means that from EDF, which is what we're supposed to do, I can just grow this out into the whole triangle. So EDF, square brackets are used for area here. EDF is 3 over 7 of EDC. This is 3, this is 4, the whole thing 7. Now EDC is 4 over 7 of ADC. And ADC is 3 over 7 of the whole thing. And there we go. So that's the ratio. Okay, so what's n plus n? N plus n is 379. Yeah. By the way, again, right, there is always a small chance that I've made a calculation error because I solved all of this without a calculator to try to, imitate what you guys were doing earlier in the day. So if I made something silly that seems a bit fishy, just do highlight it to it. Some of you saw the mock papers which I published before the SMO, and I can make calculation errors in my own mock paper as well because I'm teaching without notes. So when I teach without notes, that can happen. Without notes, without a calculator, so just let me know if something looks weird. Okay. Question 16. Eggs in a certain supermarket are sold only in trays containing exactly 10, 12, or 30 eggs per tray. For once, this is actually somewhat realistic. If you walked into NTUC, it probably is really 10, 12, or 30 eggs per tray most of the time. I think salted eggs don't come in 10, 12, or 30, but never mind. However, in terms of this question, 30 eggs is completely irrelevant. Now 30 is irrelevant because if you wanted 30, you can make it using 3/10. So 30 is completely irrelevant here, and we can just focus on 10 and 12. We want to know the largest even number of eggs that is impossible to be bought from this supermarket, meaning exactly what number cannot be expressed. So we can start off, this is how I like to solve these sorts of questions intuitively. If you bought one tray, you can get 10 and 12. If you have two trays, you can either have 20, and then each time when you switch from the 10 to the 12, you plus 2. So you can get 20, 22, and 24. Now, the gap in between is where you have numbers that you cannot form, right? Because 14, 16, 18 all cannot be formed. Now, if with 3 trays, it would be 30, 32, 34, 36. So again, there's still a gap here where there's 26 and 28 that cannot be formed. And then you have 4 trays, which is 40, 42, 44, 46, 48. And there is a gap in between still of the 38. Now once you reach 5 trays, it starts at 50. There's no more gap in between. Right? This is actually going to be connected. And it goes on. Let's say 50 to 60. When you have 6 trays, it becomes 60 to 72. So there's in fact an overlap. So 60 can be expressed in 2 ways. So after this, these blocks are going to overlap. There's no more gaps in between. So the largest one is the final gap, which is 38. Okay, we will do two more questions and then we'll take another short 5-minute break. So just up to question 18. Okay, so question 17. How many integers n are there from 1 to 2022 such that at least one of the digits of n is 2? Okay, for question like this on counting, we usually want to try to split it up as nicely as possible. And that includes that if there's any small little cases that are easy to deal with, we just deal with it first so that we can sort of like, think of it as trying to carve out something nice. You just can shave off all the unwanted stuff. Now, I don't need to worry about 2000 to 2022 because all of them contain a 2. So all of these are going to work. And there are 23 numbers in here. So I can now get rid of that. Now for the rest of it, right, I'm left with 1 to 1999. I'm going to think of it as 000 to 999 and 1000 to 1999. Now these will be the same because the extra 1 in front does nothing, right? These are actually going to be equivalent to each other. So all I need to do is to focus on the first one and see how many from 000 to 999 contains at least 1 2. The answer to that is simply, we look at those numbers that do not contain a 2. So there are 1000 numbers here. And those that do not contain a 2, there are only 9 choices at each position. So 1000 minus 729 is 271. And so this would also be 271. And our answer is just 23 plus 2 times 271. Which is 565. I'm monitoring the chat. So if my if the resolution is too bad, then let me know. But I think if it were too bad, there will be a lot more than 1 or 2 people complaining. So I will take action if that happens. Okay, we'll do question 18 before we end. And question 18 is more of like an intuition kind of question. If you understand what is going on, this is not very difficult at all. So what is the smallest k such that every subset of 1 to 99 with exactly k integers contains at least 2 distinct integers x and y such that absolute value of x minus y is less than or equals to 2? Now this is an easy question once you have deciphered what it's trying to say. And what it is trying to say, we can just break it down bit by bit. Absolute value of x minus y is less than or equals to 2 means that the difference is at most 2. Right, that's the absolute value of x minus y, it means the difference. In other words, the question is how many numbers do you need to guarantee a pair of numbers? Guarantee a pair with difference less than or equals to 2. That's the question. Now this is kind of just like a worst case scenario question, right? Well, how do we squeeze in as many that do not have a difference of 2. And that would be simply that all the gaps are at least 3. The worst case is if we just take all the multiples of 3. Right? If you have 33 numbers like this, there isn't going to be a pair with difference of at most 2. But that means that if you add one more number in, it's guaranteed to happen. So the smallest k is just 34. 33 plus 1. Again, if you want to be a little bit technical about this, how you can prove it is using the pigeonhole principle. Right? You can just put them into groups of 3 numbers. And say that if k is equal to 34, there will be at least 2 numbers in the same group. That's the pigeonhole principle. But no one's asking you for a proof. I just wanted to mention this since it is a good time for us to take our final short break. Yep, so we'll take a 5 minutes breather here, and when we're back, we will go through the last 7 questions, which is I think where all the fun / agony is. Yep, so see you in a little bit. I'm still here, just getting a drink of water, and if any of you need a short break also, you can have said short break. So once again, for anyone that just joined in, you will be able to watch back the rest of this. I mean, you can rewind it now, or in some other time you can just watch it back, right? It will still be up on YouTube for you to see as long as you possibly want. I think the main appeal of joining in now is just that you get to see all the gossip and all of the intrigue of everyone's scores and comments and all, which is, it's always a bit fun, but take it with a pinch of salt, right? There's always people trolling, and there's always people who I mean, my experience is that usually those who do very well don't like to broadcast how well they did, and then you have those who did not do so well, but say they do, and then you also have those who did not do very well and are very bold to claim it. So, you know, don't take what you hear as representative sample of how everyone fared, right? In the first place, if you're watching this, that means you're a little bit more well prepared than the average person, because you know that such a video exists. So. Okay, and just keep the discussion in the chat civil, please. For round 2, I will see how things go. So I probably will try, but I don't know whether I'll be able to come out with a live session because I mean, I do have lessons scheduled is one thing, and the other thing is that it is one thing to agree that I'm going to prepare the solutions to around one set within an hour. It's another thing to commit to that for the second round. That is something that no one would dare to promise, including me. So maybe I'll just record a video after that, but I'm not sure if I'll be able to do it as a live stream. It's a little bit risky. Anyway, right, so let's continue. This is taking less time than I have to admit I would have thought. I didn't have any conception of how difficult the paper is, or what kind of questions it is, or how I'm going to explain it before this. I told you that just saw the questions basically at slightly past 1 o'clock. And yeah, it's funny because when I saw the questions, I felt that it was not an easy paper. But as I say it out loud, I know it sounds like it is quite an easy paper. And that's because a lot of the solutions are short but not obvious. Right? There are a lot of these questions with short but not obvious solutions. So, meaning that if you knew what to do, you have more than enough time to finish a lot of questions. But if you don't know what to do, you can't even write down one line meaningfully. Yeah, and speaking of line, we have this question here, which is the typical geometry question where you stare and stare and stare and are not quite sure what to do. Because the only angle that you appear to be able to find is the 30 degrees down here. And that seems to be all. So what do we do? I am sure some of you took out a protractor. And if you did take out a protractor, I think this is not that poorly drawn. Right? The answer is 30 degrees. I think it is quite close to 30 degrees as well. As to how do you actually go about solving this properly, this does resemble one of the old SMO junior questions. I think it's 2013. Some of you have a book there you can check, right? There was a question similar to this with some length ratio here and a bunch of angles. Now, the construction that I'm going to do is probably not the only one, but I would like to draw a right angle, drop a perpendicular over to here. Let me try again. I'll call this point E. I don't want to say too much about protractors, right? It seems that some schools allow it and some schools don't, and you can complain to your teachers if they are the ones that don't allow it. Now, why is it that I draw this right angle here? Because in any right angled triangle, there's this property that the length of the median is going to be also equal to the other two lengths. This is basically in a semicircle. You don't need to draw the semicircle, but I'm just going to put it there for show. Basically, when you draw a right angle here, if a right angled triangle and you connect to the midpoint, that length will be equal to the other two lengths here. This is going to be all equal to the length of the radius of that semicircle. So I want to do this because it gives me some nice stuff. What are the nice things? Well, the first nice thing it gives me is that because this is 30 degrees, this is 60 degrees, so this is actually going to be an equilateral triangle. So AE is also going to be equal. The second nice thing it gives me is that this triangle here is isosceles, so this is also 30 degrees. And if this is also 30 degrees and it's the exterior angle of triangle DEB, that's also 15 degrees. And if that's also 15 degrees, it means you have another isosceles triangle, so this length is also equal. And so it implies that triangle DEA is just a 90, 45, 45 triangle. And x is equal to 30 degrees. Yeah, so answer is 30 degrees. And this is one of those cases where if you knew trigonometry, which is the SMO senior staple, if you knew trigonometry, this is going to be quite simple. You can just use sine rule here and there and you'll get something. But if you don't know trigonometry, it's still doable. And I'm quite sure that the construction I gave is not the only one. However, you do need to construct something. Now, what that thing is, I really cannot give you a whole list of other things that work. I'm just giving one that came to mind straight away when I saw the midpoint in an angle question. This is one of the most straightforward ways to use a midpoint condition when we're dealing purely with angles and nothing about length or area. Okay, question 20. Now, question 20 is very suggestive. If you take the suggestion, then you will solve it. If you don't take the suggestion, you will be very puzzled. In fact, I set a question very similar to this for some of my students in preparation for the SMO senior. Except that I did not give them sum of squares, I just gave the numbers inside with a different set of values. And then everyone proceeded to think of using Heron's formula. Now, you do not want to use Heron's formula on this, not because it won't work, but because it is going to be horrendously messy. If you don't know what's Heron's formula, don't use it anyway for this question. Now, this suggests Pythagoras. Right? It suggests Pythagoras, meaning that it looks like there is a 6, 7, and this hypotenuse. There is a 12, 7, and this hypotenuse. And there is a 6, 14. And that hypotenuse. Of course, you also would notice that there is 7 plus 7 is 14 and 6 plus 6 is 12. So if you do a little bit of mathematical jigsaw solving, you would realize that this actually can be fit into a single rectangle. Okay, round 2 practice papers, I'm not sure. I'll see if I have time to come up with any questions. It is, however, quite easy to find question resources for round 2. because 5 questions, 4 hours is the length of contests like the APMO, like the Balkan Math Olympiad, like the CGMO, CWMO. So you can find resources for that a little bit more easily in terms of the format. So here I'm just stalling for time and talking about some of your stuff in the chat while I am busy drawing this. Yeah, in terms of questions, yeah, I did manage to get hold of the questions because all of you get to bring it back, including my students as well. That is true. Okay, so we have got this figure here, and now finding the area of that triangle is very easy. Right? It's just maybe, if you did not think of drawing this, you would have not much idea how to proceed. Okay, so it's just the big triangle minus the area of these 3 triangles. So subtract everything off and you do get 63 as the area. And so when you see all this square root stuff, it is very suggestive of being something Pythagoras related, especially when it is to do with area. Right? It means that this is a geometric problem. So try it out, and 6 plus 6 is 12, 7 plus 7 is 14, so it fits in this way. Okay, question 21. Yeah, so for question 21, I know some of you did it just by estimation because you say, oh, this is going to be an integer answer. Yeah, that would work if you did it by estimation. But there is an identity associated with all of this. Now, the hint in a sense is that you have 1 over x that is important, not really x. So I want to figure out what's going on with 1 over x. And this expression here at the bottom, now this is cube roots. There isn't really a normal conjugate for cube roots, but this expression is in the form of, let's say, z squared plus z plus 1. If you know your cube identities, which are very pertinent since we have cube roots, you would realize that there is this identity on the difference of cubes. Here I'm applying it specifically to the case where you're working with something in this form. So what you need to do is to multiply the top and bottom by the cube root of 2 minus 1. And using our identity, you get the cube root of 2 cubed minus 1. Yeah, I'm just writing this a bit more slowly to make the aha moment a bit more satisfying. Right now, cube root of 2 cubed is 2, 2 minus 1 is 1. So that's all gone, and you just have cube root of 2 minus 1. Yeah, so the first observation is that 1 over x is the thing that really matters, not so much x itself. The second observation is the 133. Very suspicious, right? And in fact, it looks very much like 1 over x plus 1 cubed. If you expanded that, it will look almost precisely like this. Except without 2022. That's just the typical appearance of the year number. So 1 over x cubed plus 3 over x squared plus 3 over x plus 1, these are all in there. But 1 over x plus 1 is cube root of 2. which means that 1 over x plus 1 cubed is 2. And so therefore, your answer would just be add 2021 to it. So 2023 is the answer. Okay, question 22. Yeah, see someone saying brute force? Yes. I think for, like, to be fair to the organizers, they have done a fairly good job of not overpopulating the paper with questions like this. So I think we can give them a pass for including one question like this that is pretty much just bashing. It is within reason. It is not like 20 questions were like this. That would be a horrendous paper. So this is fair. And we are asked to find this for some integers a, b, c. Now that's important that it says some integers a, b, and c, because there are a lot of weird concoctions that we could do if we allow a, b, and c themselves to include square root 3, square root 5, and square root 7. Now, because there is the information of integers, what we can do is to just cross multiply and sort of compare coefficients in a way, meaning that the coefficient on square root 21 must be the same on both sides, the coefficient on square root 15 must be the same on both sides, and so on. So I'll cross multiply and we'll see what we get. We know that 15, 35, and 21 are just 3 times 5, 5 times 7, 3 times 7. So that's where they all come from. And this is not so nice, but let's just write it down before expanding it. The whole thing. And we need to figure out how this is going to be equal to the left-hand side. Now what I would do is to just extract out the coefficients. Right? Now for square root 15, there's 2 on the left side, and it will have come from these 4 on the right hand side. So it will be square root 3 times b square root 5 and 2 square root 5 times c square root 3. So b plus 2c will be the one with the square root 15. Now if we have square root 35, it is going to be the square root 5 and square root 7s that will be relevant. This is way too light to have anyone read it. So 2a plus b is equal to 2 as well. And then we'll do the last one for the square root 21. This time it will be 3 and 7. So a plus c is equal to 2. Now this is not just solvable, but pretty easy to solve, right? Because from the first 2 equations, you can tell a equals to c. And from the bottom equation, it means that a equals to c equals to 1 and b equals to 0. Which is very underwhelming. But we can check that if a and c are 1 and b is 0, then the integer part would be square root 3 times square root 3 times c. So it would be 3c plus square root 7 times a root 7 plus 7a, and then 2 root 5 b root 5 10b is equal to 10, and this checks out because this is 3, this is 7, this is 0. So it means that really a equals to c equals to 1, b equals to 0 is correct. And so a plus b plus c is 2. Question 23. How many integers n are there from 1 to 2022 such that the floor of the cube root of n is a factor of n? Now this is the sort of question when you see a floor function being mentioned, right? Now think about how many different values can that floor function actually be equal to within the scope of whatever the question allows the variable to be. Now from n equals to 1 to 2022, the cube root is not going to be that big, right? So if you know a few cube numbers around 10, you know you're not going that far. 11 cubed is 1331, 12 cubed is 1728, and 13 cubed is 2197. Now it means that the cube root of 2022 is 12 point something. So this only really goes from 1 to 12. So if this only goes from 1 to 12, we don't really need to worry about solving this like algebraically as an equation. We can just understand each of these cases, and either we list out until we finish listing, or we list out until we find a pattern so that we don't need to finish listing. So I'm going to list out a few first, and there is of course a way to do this purely algebraically without listing the first few cases, but I want to be quite practical in terms of if I'm doing the SMO, this is how we would do it. So if this is 1, that means that n would have gone from 1 to 7. And I'll just say the number of valid choices is just all of them from 1 to 7. So there are 7 of them, right? 1 is a factor of everything. Now if it's 2, this will go from 2 cubed, which is 8, to 3 cubed minus 1, which is 26. And we're taking all the even numbers for the range 8 to 26. This is 10 of them. For 3, we go from 27 up to 4 cubed minus 1, which is 63. And we look for all the multiples of 3. And let's just do one more and you probably see the pattern. Now this is a pattern that's not very difficult to establish algebraically, but I think I'll leave that as an exercise, just like every teacher likes to say. Right, so the pattern is pretty obvious, it's just plus 3 each time, and it is algebraically not difficult to verify. What's the significance of this? Well, it's only going up to 12, right? But the last one at the end, you always need to be careful because it's truncated at a weird place. 2022 is only there because, well, there are two reasons why 2022 is there. One is that it's 2022. The other reason, some of you are in the know of how that happened. So all the way until we have 11. You can either divide or just continue from the pattern. I'm just going to say that this is 10 steps later. So based on the pattern, it should be 37. Based on the pattern or the thing you verify algebraically. And then we have got the last bit, which is not quite reaching the end. So we can't follow the pattern there because it doesn't reach 2196. It just goes up to 2022. Now 2022 is not a multiple of 12 because it's not divisible by 4. Right? It is divisible by 2 and 3, so it's a multiple of 6 but not 12. So the closest one would be 2016. And there are 25 down here. So then we just add all of this up. There are 11 numbers, so 7 plus 37 over 2 times 11. 22 times 11 is 242. And then 242 plus 25 is 267. And I'm sure at least some of you know why this is significant. I'm not going to get into that, but there's going to be a lot of rancor in the chat in a few seconds time, I think. Okay, we are left with a couple more questions. Okay, question 24 is possibly guessable, but I mean that would be if you really guessed a lot of things, because there are lots of things you could guess that would not work. First to mention what it is, right? Because some of you just say, hey, I guessed it, right? It is x equals to 0, y equals to -1, and the answer is 8. Of course, this is not the solution. I'm just addressing the answer straight away because it is somewhat guessable when you have, if you tried various small values. Now, I think there's more than one way that you can solve this, but I want to go with the more straightforward approach that we know, which is just by completing the square again. So what I want to do here is to first view this as just a quadratic in terms of x only. So I'll write it like a quadratic in terms of x only. And I will complete the square. So x squared plus 2y plus 2x means that it becomes x plus y plus 1 squared plus, I don't actually care what's behind. Now, why do I not care what's behind? I'm trying to say that, well, what value should x be? X should be equal to -y plus 1. Because if x is anything else, then by adjusting it to -y plus 1, it is going to give you a smaller value. Right? So in terms of y, x must be -y plus 1. Now I can substitute this in here, but I think that's a little bit messy. It can be done without too great an issue. But I think the funny thing that we can do here is to reverse the perspective now and say, okay, now I'm going to view this as a quadratic in terms of y. And I mentioned that actually the thing behind doesn't matter. I will factorize this and complete the square. And this time, what that tells me is that for any choice of x, y must be equal to negative of this. In order for it to work. So now we have got a pair of simultaneous equations for x and y. We just need to find out which of them is going to give you which pair of them is going to satisfy both of these, and that must be the smallest possible value. Okay, so we can just substitute in either way. Yeah, and solve this. Just rearrange it, and you would find that y is equal to -1, and after that, put it back in, x is equal to 0. Okay, so this is the minimum value. So you substitute back in happily and you would find your answer to be nothing more than 8. Okay, let me reiterate that these are my solutions. These are not the official solution by the problem setter, if you weren't here at the start. So that means that maybe the question setter is a different idea in mind. Maybe it's simpler than what I have. Maybe it's more complicated than what I have. I have no idea what the question setter is thinking. I'm just treating it as if I were a student doing it for the first time, this is probably what I would do. Okay, finally, question 25. The one where some of you did a lot of extensive artwork to solve. The diagram shows a rectangle that's partitioned into 17 squares. I'm not sure if you guys actually took a ruler, right? So I know rulers are usually allowed. If you took a ruler and you measured it, most of these are actually going to be squares, or very close to a square in terms of actual scale. So there is only one way to fit it in like this. And so technically speaking, it has to be to scale, and if you measured it, you would not be wrong unless you measured wrongly. But of course, we are not supposed to be measuring our lengths. So here's what we can do. I'll just put a 2 in there. And then we can start by just letting one of the squares have length x. We'll fill in as many as we can until we have no choice but to solve for x. Right? You just fill in as many as we can in terms of x. So I'll pick one nearby, like this one, and I'll call this one x, the side length that is. So if this is x, then this will be x plus 2. This will be x plus 2 plus 2 is x plus 6. Those on the left and right will be x plus 8 and x plus 8. The one on top here will be x plus 10. And so this length here is x plus 8 plus 2 minus 10. This is 10. The one on the left, 10 plus x plus 8 is x plus 18. The small square here is 10 minus x. And then this square down here would be x plus 10 plus 2 minus x plus 2. Right? I'm using this line here. So that would be also equal to 10. Okay, at this point I'm going to pause a while because I found so many lengths in terms of x that surely some equation must be formed. Right? It has to be possible. Now, how would that work? Well, I think we can do something like look at this portion here. There we go. Right, this portion. And look at the part below. Now, of course, they are the same length, but we get it in two different ways. Right, at the top, 10 minus x, 10, and x plus 10 is 40. So it means that this portion here, this is 40. This one is 3x plus 22. So x should be equal to 6. And we can now fill in everything in the bottom half. You don't need to use these particular ones. You can just stop anywhere the moment you feel that you have found enough lengths in terms of x that you can actually put down an equation which is non-trivial. So I'll just write down all the lengths now that we know x is equal to 6. So then we can kind of do this again for the top half, because I don't see a very simple way to find the length of the top half squares, but we can just write it, and now there's a lot less than before. So I'm going to call this length here the small square y. Again, you can kind of measure it and guess, right? But I'm just writing all of it down. So this is y. Then this portion here, 10 minus 4 is 6, so this is y plus 6. This is 2y plus 6. This is 3y plus 6. And this is 3y plus 12. So I can now measure the entire length here. This is 8y plus 24. And as for the bottom, 24 plus 14 plus 12 plus 14 is 64. So y is equal to 5. And again, I can fill in all the actual lengths. 5, 11, 16, 21, and 27. Kind of makes sense that something has to be odd, right? Because if it weren't odd, there's no reason to make the length of those shaded squares 2. They'll just let it be 1, which is usually how things are. So you should secretly be expecting something to be odd for this to make sense. Okay, so then we just need to calculate. The length here is 51. So 51 times 64. Yeah, it's a bit unfortunate to calculate it wrongly, but I think you'll be fine. So 3264 is the area of this rectangle. Okay, and there we go. So this is the last question, question 25. Alright, so what do we do now? Well, pretty simple. Yeah, we are done. If you want to stick around to chat a little, you can. I'll leave the stream on for another 5 minutes or so. If you're taking the SMO Open tomorrow, all the best, and please rest up. If you took the SMO Senior but you just joined in, well, thanks for being here, and I'll see you tomorrow. The Senior streams at 2:30 and the Open one's at 6:30. I'm a little nervous about that because it means I will have basically an hour and a half to prepare for the Open one as well. The reason for the timing is because I don't want to occupy tonight for those of you taking the SMO Open, but some of you are going to be in the SIMO camp on Friday, which doesn't leave me with a lot of time. So that's why I am squeezing everything on Thursday. Okay, so thanks everyone for joining in. Yeah, last YouTuber comment, please like the video, please subscribe if you want to see more. Round 2 stuff, I can't promise it, but I will potentially be doing some stuff for that, whether it's just reviewing some of the past year problems or it be setting new questions. You see how much time I have to record videos for that. Okay, so yeah, thanks everyone. Like I said, I'm going to go off camera now. You can leave if you want. If you want to chat a little bit, you can first before I end the stream. So hope it helped. Alright, thanks everyone again. I think I will close the stream now. So if there's anything that comes up after, just leave it in the comment section below.